Right, good morning, grade 11s. It's Tuesday, the 9th of June, and today we are going to look at trig equations. So, yes, you have done trig equations in grade 10, but we are going to do the full-on trig equations in grade 11. Okay, so I'm going to do each one on its own, and then we will look at some exercises. Okay. So the first one, the equation for sine theta is equal to. Now, what do I need to remember? I need to remember two things. Well, either or, but you need to remember that. Using my cast diagram, I know that sine is positive in my first quadrant and in my second quadrant. What is my first quadrant? It's a normal acute angle. What is my second quadrant? It is 180 minus theta. Okay. What do I remember about the sine graph? That the period, time to take or do a complete sine graph is 360 degrees. Now, in grade 10, if I say 2 sine theta is equal to 0,5, solve for theta, you would have said to me that sine will become sine to the negative 1, 0,5, and you would have had your reference angle, which is 30. In grade 11, I want to say to you, well done, but that's only half of your answer. Because what do you know about sine of 30? Sine of 30 is the same as sine of 150, because sine of 30 is in the first quadrant and sine of 180 minus 30 is 150 is the same in quadrant 2. So if I say to you sine of theta equals 0,5, it means my y value is 0,5. So here I've taken a diagram so that you see that. So that line there is y 0,5. So if I go and sketch my normal sine theta graph, it means it goes through 0 at 90, it peaks at 1, goes through 180, 270, it's minus 1, 360 there. So what do I notice? That at 30 degrees, they are equal. That's exactly what I wanted. I find the same at 150. So what does this mean? Sine of 30 is the one that I get in my first quadrant. Sine of 150 is the one I get in my second quadrant. Okay. So when we talk about solutions or equations in grade 11, we talk about general solutions, meaning which options will all give me the same answer. Okay, so the first one is theta is equal to the reference angle, which is your acute angle, or you can say sine to the negative 1 and whatever they gave me to y's value, plus k times 360, and k can be any integer. Now let's talk about where that k times 360 comes from. The 360 comes from, it takes 360 degrees to complete one graph. Okay, the k value is how many do I want to complete. So we're going to look at the k later. But that's not only the first quadrant I can find sine, I can find it in the second one too. So I can also have theta equals 180 minus my reference angle plus k times 360. So what does the k mean? The k means I want to know how many times do I have a valid answer within a range. So for instance, minus 90 to plus 360. I'm going to show you later on how we choose value for k, and I get different answers which I can choose from. Okay, so let's stick to sine theta first. And if I say to you solve sine theta is equal to minus 0,5, I know sine theta will have two possible answers. One in the first quadrant, one in the second quadrant. The first quadrant, I will use the sine to the -1, and whatever y value is given, I will get an acute angle. The second one, I will take 180 minus that acute angle. That's my two answers. So the first one, sine to the -1 equal or times minus 0,5, and because it's general solution, I have to add k times 360, and anywhere as long as I state it, I need to put down k is part of an integer. Okay, so it can be either minus 30 plus k times 360, or the second quadrant is 180 minus 30, so a minus and a minus becomes a plus. That's 210 plus k times 360. Okay, so what does an actual example look like? So if I say to you, determine the general solution of sine theta equals minus 0,47. I know the general solution for sine is 1 of 2. So theta will equal the reference angle plus k times 360, or theta is equal to 180 minus the reference angle plus k times 360. One of those two. So I've worked it out first. The acute angle, sine moves over, becomes shift sine to -1 minus 0,47 plus k times 360. The moment I write down k times 360, it goes in hand with k as part of integers. Punch that into your calculator. I get it's minus 28 degrees plus k times 360. I'm going to take that minus 28 degrees as it is and put it into my second option. So 180 minus 28 plus k times 360. The moment I write down k times 360, I need to put down k as an element of integers, and I get my option. So where does k come into play? When I ask you, determine the solutions in the interval of minus 360 and 300. Minus 360 and 360. So when I ask you determine the solutions, I tell you to substitute k with any integer. So what is my integers? I usually start checking at minus 2, check minus 1, check 0, check 1, check 2. Okay, so the easiest way I will do it is the following. So my two options for sine theta is theta equals to minus 28 plus 360. That will I write down in my first column there. And my second option is 208 plus k times 360. I'll write it down there. So I chose k equals to minus 1. So I'll have minus 28 plus minus 1 times 360. I get minus 388. If I say 208 plus minus 1 times 360, I get minus 152. There, I'm going to substitute k minus 1, k0, k1, k2. Now I'm going to check. I want minus 360 and 360. That one doesn't work. This one falls in the interval. That one falls in the interval. Interval, that's okay. That is out, that is out, that is out. So, theta will be minus 152 degrees, or minus 28, or 208, or 332. That is my four options for them. Right. So what are we going to do with the cos graph? Oh, not the cos graph, the cos equation. I'm not going to have a straightforward equation. I have to be able to get all the options, so the general solution. So what do I have to remember about cos? In my cos diagram, it is positive in my first and my fourth quadrant. 360 plus, 360 minus. A cos graph has a period of 360. So if in grade 10 you were asked to solve theta, you would have said that cos will jump over, it becomes cos to the negative 1 of 0, 5. That is 60 degrees. So theta will be 60 degrees. Now that was only focusing on the first quadrant. What am I going to do with the second option? So it's either going that way or it is going this way. So this is positive angles, that is negative angles. Okay, so when I look at a cos graph and I say it's equal to 0, 5, if I draw the 0, 5 line, it is there. Now what do you notice? There's my 60, they are equal. Then they equal again at 300. Okay? So I have 360 minus 60. Then I get equal. So 360 plus 60. And I will see it always happens in those two. So how do I know? The moment I ask you to write down the general solution for cos, what do you write down? Cos is plus minus the reference angle plus k times 360. The moment I write down k times 360, I need to write down k as part of an integer. Example. So if I say solve cos theta, I will move the cos over, which becomes cos to the negative 1 times minus 0.5. Okay? But I will not just move cos over as a plus, it will be plus or minus. So plus minus shift cos minus 0, 5 plus k times 360, and k is an element of integers. So I have plus or minus 120 plus k times 360. What does it mean? I still have two options because it's still in two quadrants. It's either a positive 120 plus k times 360 or a negative angle. Negative angles is anti-clockwise, which is there, or clockwise I mean. Positive angles are anti-clockwise. And there's my second option. Okay. So let's look at a second example where I ask you to use k as well. So given the equation of 2 cos theta equals minus square root of 2, determine the general solution. So the moment you hear general solution and you see cos, you need to know theta will be equal plus or minus cos to the negative 1, whatever the value, plus k times 360, and k is part of integers. Okay, that you should know off by heart. What does that mean? I will have to divide each side by 2. So I get cos theta equals minus 2 square root 2 over 2. Because we have a general solution, I am going to move the cos over, but I will have a plus or minus in front of it. Plus k times 360, and k is an integer. So when I work it out on my calculator, I get plus minus 135 plus k times 360. That means I'll either have minus 135 plus k times 360 or plus 135 plus k times 360. Determine the solutions in the interval minus 180 and 80. So solution means choose values for k. So I went and I chose minus 1, 0 and 1. these are the answers I got once I substituted k. So minus 495 is out, minus 225 is out, minus 135 is in, 135 is in, 225 is too high, and 495 is too high because I'm only allowed to work between minus 180 and positive 180. Okay, so the last one, tan. So if I have tan of theta, an equation with that, I need to remember the following. Tan happens or is positive in my first or my third quadrant. But, very important, it only takes 180 degrees to complete a tan graph. So it's either on that side or in that side or at the top or at the bottom. Only 180 degrees at a time, not more. Okay, so if I look at my graph there, I see that in 180 degrees I only have an up or a down. So when I read general solution for tan, tan is my special child. So where sine and cos had two options, tan, which is my special child, only has one answer. Okay, so the general solution for a tan equation will be my reference angle plus k times 180, and k is part of integers. All right, so if I give you an example, I will say to you, solve for tan theta equals 0,5. Because we're busy with equations, tan will go over, become to the negative 1 power, and then I will have to add k times 180, and I need to write down k is an element of integers. If I punch in shift tan 0.5, I get 26.56. Okay, so determine to correct to the nearest degree the solution of tan 2 theta. Now I chose this one because there is a watch out, and this watch out counts for sine and cos as well. We are South Africans. We read from left to right, so we clean from the left to the right. So when I have tan 2 theta equals minus 2,147, I first get rid of tan, or tan moves from the left to the right. So 2 theta remains. If I work out shift tan minus 2,147, I get minus 65,02. When I divide by 2 to get theta alone, I need to divide each term by 2, including the k times 180. So 2 theta will become theta, minus 65,02 becomes minus 32,51. Important, k times 180 becomes k times 90. Okay, so finding solutions, choose values for k. I chose only positive values because I'm only interested in positive answers. So I chose k, 1, 2, 3, and 4, and I see that all 4 of them, 58, 148, 238, and 328, will be options for theta. Okay, so we're going to practice this a lot because you are going to feel flustered about this. I'm sure you'll get it right. So what am I going to do for homework? Exercise 7.10, number 1, it's 4, 5, and 6. And then number 2, that was a typo, there's no number 3. It's question 2, 5, and 6. And then use the PDF to mark your work.